Good afternoon and welcome to this quick little session on harnessing data in real time with infinite storage. Basically, how you can combine SAP products with Hadoop to get a data fabric that will allow you to work with large amounts of data and still get real-time performance. Data content is changed this world in ways we can't imagine. 90% of the world's data was created in the last 2 years. 500 million photos are uploaded, and 48 hours of video uploaded every minute. We've got 61% of enterprise technology projects are funded by business units and not IT. So we're not necessarily selling to the traditional IT vendor. We are selling to the line of business. The problem we're facing with this new way of doing business, the problem we're facing with the new amounts and types of data we have, is the traditional data infrastructure does not work. And it's driving the need for new solutions, such as Hadoop, and hence this conference, and why people are here learning about Hadoop and how Hadoop can help deal with big data. And when we take a look at the types of data, they aren't the traditional structured types. We're looking at clickstream. We're looking at sentiment analysis or text. We're looking at geospatial data. So we need some way of driving this. There is an economics of big data. There are massive amounts of data types. There are vast amounts of money that can be made and optimized. 60% potential increase in retail operating revenues by properly using big data. And by that, they were talking about not just sentiment analysis, but also spatial, how and where people are. So there's a lot of money can be made, and there's an urgent need to bridge that gap. And to bridge the gap, you can use Apache Hadoop with its different types of projects, distributions, and data scientists. So big data is more than just Hadoop. Yes, Hadoop can do an awful lot, but along with the exploding business volumes and the data variety that I talked about earlier, and the accelerated flow of data in, we've had changes in storage and memory and in CPU processes and architecture. We have data mining and predictive analysis. We have in-memory computing, and we have complex event processing. So Hadoop brings certain things to the table, and the advances in Hadoop are driving a lot of technology, but you still need to add a few other pieces. In-memory computing, such as SAP HANA. Complex event processing, such as SAP can provide. And data mining and predictive analytics. SAP HANA has predictive capabilities. We have SAP Infinite Insights, a product acquired when we acquired KXCN for predictive analytics. All that together gives you enterprise big data. And that is really what people are after at this point in time. Because as I mentioned earlier, most of the buyers, most of the decision makers aren't IT anymore. Most of the decision makers are driven by outside line of business people. There was a statistic there. SAP, along with a few other sponsors, co-sponsored an EMA Big Data Survey. And the Big Data Survey actually looked at 300 respondents who are driving some 650 data projects, big data projects among them. And the survey noted, interestingly enough, that only 2 out of 10, 1 out of 5, 20% of all big data projects were actually funded by IT. The other 80%, primary funders were not IT. Primary funders were a line of business. So you really need that enterprise scale, that enterprise volume to bring that capability. And that is where you get the power of HANA and Hadoop together. SAP HANA, Infinite Insights, and Infinite Storage. So you get real-time predictive analytics with the SAP Analytic Applications, Business Objects, KXCN Infinite Insights, or SAP Infinite Insights now, in HANA, an in-memory database, combined with Hadoop. And Hadoop, as much as this says infinite storage, is more than just cold storage. It is something where we can actually drive processes in the Hadoop end of things and move that through into HANA. So I can actually pre-process data in Hadoop, I can do real-time analytics in HANA, and I can get the best of both worlds. I can get massive amounts of data of unknown value, and I can have rapid, instant insights in value that is high data. So I have high data, time-sensitive, critical data in HANA, things I need immediate response on, and I have a large data lake that I can do pre-processing on, that I can process, that I can explore. And I can drive that value back, and I can lever the two pieces. Two ideal candidates working in synergy. And this is a use case that actually really speaks to that need for the synergy and explains how data is growing beyond what we can traditionally deal with. So we have an explosion of biological health information that has surpassed our ability to deal with it in our own minds relatively quickly. There has been a 20 to 40% annual increase in medical images that are stored and archived. And when we take a look at this, as I said, we've got a gig for CT scans up to 120 megabytes of mammograms. When I take a look at genomics, and this is the use case I'm going to talk about, when I take a look at genomics, we're looking at 800 megabytes of data per genome. I'm looking at 300 terabytes looking at known cancer variants. And I've got 200 terabytes of all the other known variants and 15 petabytes of data that I need to look at. How can I analyze all this data? How can I get real-time insights? How can I get something actionable out of this? And SAP worked with a company out of Japan, MKI, to do analytics for personalized medicine. And in this process, what they're actually doing is they're doing pre-processing and alignment of the DNA sequence from cancer to normal. Some of the steps still take time. I have to draw the blood, I have to get the genome. But when I start doing the mapping, when I start doing the data analysis and doing the variant calls from pre-processed sequences, doing combinations to see where the variants are and how this works, and I take a look at that, I can take the time that used to take, which is a couple of weeks, and I can get it down to a couple of hours. And that really makes a significant difference to someone who is waiting for cancer treatment. I go into a doctor's office, and no longer does it say, come back in 2 weeks. It's sit in the waiting room for a little bit of time. And all of a sudden, I know how and what to do. And when you're dealing with certain types of cancer, waiting a couple of days, let alone a couple of weeks, can make a significant difference to when treatment starts to what the outcome will be. So this really is a case of big data changing lives, and really a case of infinite storage combined with instant insights. And I can take a look at all the related medications, how things work. And this is where it talks about personalized, where it comes down to personalized medication. Because you can't just say cancer. I may have cancer, and I may have a particular type of cancer. But the cancer I have is unique to me and unique to my genomic makeup and to the variant that I have. And that means different medications and different courses of treatment will have different outcomes. And I really need to make that match as clearly and as predictably as possible. So, as I said, we used Hadoop for pre-processing. So this is an ideal use case of, I showed you the amounts of data in terms of this. Massive amounts of data, pre-processed in Hadoop, put into SAP HANA for that advanced analytics, for that matching. And the original data process, as I said, 2 or 3 days to process, take a look at specimens. It's down to 2 or 3 hours. And I can actually accelerate the process down, in this particular case, and this is an ideal case, but down to 20 or 40 minutes. That really makes a significant difference to someone who is sitting there waiting for cancer treatment, waiting to have a known outcome. And again, one of the things that I'm asked at normally when I come to these conferences is R. R in terms of predictive, R in terms of statistical. And this particular use case does speak to that. It wasn't just, I talked about preprocessing in Hadoop, I talked about using SAP HANA. R is also part of this in terms of the statistics. And I talked about the speed. We're talking 400,000 times faster, 216 times faster DNA analysis from 2 to 3 days down to 20 minutes. And the benefits really are people-driven. I can say it's optimized treatment plans based on DNA mutations. I was doing that before, but now I'm doing it in 20 minutes. I can say I can accelerate. What it really means is I've impacted someone's life. I've made a change to how quickly they can be treated. I've made a change to their state of mind, because in an afternoon, they have a treatment plan rather than in a week they have a treatment plan. And it really, really substantially makes a difference. The core of all of this, I talked about preprocessing in Hadoop. The core of all of this is the SAP HANA platform, and it is more than just a database. SAP HANA is a columnar in-memory database, but it is more than just a database. It is a platform. It has spatial capabilities, it has predictive capabilities, it has text analysis capabilities and text mining capabilities. It has business libraries, it has rules engines, it has planning engines. So far more than just a database. It really is an entire suite of products in a single platform, down to an application server in what is the database, that can, through integration services, work with structured, unstructured, machine data, geospatial data, and take in information from Hadoop. And this really changes how you do business. How do I get that information? I talked about one of the data sources. I talked about one of the data sources being Hadoop. How do I get the information from Hadoop into SAP HANA? And there are a couple ways of actually combining SAP HANA, in-memory, real-time, with Hadoop, the large storage in which I'm doing pre-processing. The first way is to actually go in and use ETL. I can basically take the data out of Hadoop. I can physically move it into SAP HANA and put it in memory. And I need to do this. I mean, when I talked about getting sub-second response, when I talk about real-time, the data has to sit in HANA. The applications ideally are built for the HANA application engine that is part of that database platform. And I move the data basically from Hadoop into HANA. And data services actually has the capability to do text processing. I can do entity extraction and drag it in. It is high-performance read and load, and I can use the extended optimizer from Hive, QL, and Pig. The other thing that I can do is smart data access or data virtualization. So I don't actually move the data from Hadoop into HANA. And there are use cases where I need to. As I mentioned, if I'm going to get real-time speed, if I'm going to get real-time capabilities, I have to have that data sitting in HANA. But there are times when the data can sit, and the query isn't that time sensitive, can sit on another database. It can sit in Teradata, it can sit in Hadoop, it can sit in another HANA instance, it can sit in SAP IQ. And I can actually start a query in HANA and have that query pushed down, in this case through Hive into Hadoop. And that push down has some benefits. As I mentioned, I'm not actually moving the data. I create what is a logical or virtual table in HANA. As far as the applications are concerned, they're accessing a table in HANA. As far as the users are concerned, there's a table in HANA. Same as other tables in HANA. In this case, however, this table doesn't hold real data. It actually is a pointer off to the other data server or data store. And it will actually cause a job to run on that data store and return the results set through the table. That means that I am now tied to the latency of the target system. So, as I said, there are times when I need that time-sensitive data in HANA. There are times when I can leave the data in the target system, i.e. Hadoop, because the query itself isn't as time sensitive, and I can wait for the other database to respond and fill the table. Now, that said, I can actually set the table so it's not static. Anytime there's a change, anytime there is processing done in Hadoop, that table is updated as far as the users are concerned in writing their queries and in pointing to that table. The table is as up to date as HANA has it, as Hadoop has it. And it isn't that hard to make that pointer. It's fairly standard OBDC drivers right now into Hive with Hadoop. But it also means that I can start a query in HANA, and as far as everybody is concerned, the query runs on HANA. Processes, users. It actually kicks off a job in Hadoop and returns the result set in a fairly seamless manner. It means you don't need to have any specialized capabilities. And it gives a non-disruptive flow to your data fabric. But this really, truly does bring in a data fabric. You've got HANA with its capabilities driving the process as a central point of access, but it's pointing off to the entire data structure that you have in your fabric. And the slide's not advancing anymore. If you could go to the next, there we go. Just have to push it 4 times. So, big data as a platform scenario. There are different types of big data I mentioned earlier. Some of them are the Internet of Things, machine to machine. Sensor data, mobile data, Internet of Things. These are basically background used on devices that drive real-time decisions, predictions, and optimize performance, either on their networks or allow me, through looking at what's come in, to take a look at how things are working. The other side is the omni-channel data insets, unstructured, multimedia, real-time, social. This geospatial data, a lot of this is user-driven and user-supplied, and I'm getting insights from high-volume variety of data for real-time analytics and actionable insight. And the two of these work together to create what we have as an expanding frontier. So we have the corporate functions that are core of this, because we're still selling to line of business. And we're looking at bringing in things that bring customer and audience behavior, whether it's sentiment analysis, whether it's geospatial information that can be used to drive sales, to drive understanding of consumers, to drive supply chain, on through to the Internet of Things, where I have machines talking to each other and giving me sensor feedback, through to the logical data warehouse I described before. No longer do I just have a single database. The EMA study I talked about earlier, 60% of all customers running big data projects have at least 2 databases that they're actually utilizing to lever that project. There will still be archiving, but the archiving will no longer be the way it was to tape. When I archive data now, I can archive it into a structure, be it SAP IQ, be it Hadoop, which is a live, active archive. The data is no longer gone. The data is still accessible and actionable. And we're moving to the cloud. We have HANA Enterprise Cloud, we have HANA as a platform, and we have HANA as a service. All of that tying into big data with the elastic storage, and that's where Hadoop comes into this. With the deep exploration analysis, again, where Hadoop complements SAP products. I have infinite storage that I can do my data exploration and analysis on. I can visualize this. I can use big data visualization. SAP Lumira is a product that provides vivid visualization, helps people understand what it is the data is saying in an insightful and in an instinctive way. And Lumira itself is able to tie directly into Hadoop. So I can do my exploration, and I can do my presentation of information that I found through Lumira, and I can actually go directly down into the database itself. I don't have to go through HANA. I can actually go straight into the Hadoop platform. This is basically a view of the world. You have SAP HANA. It's an in-memory platform. The SAP HANA platform for big data is scalable to the petabyte scale. In fact, SAP recently reclaimed the Guinness World Book of Records for the largest enterprise data warehouse. And it was a combination of SAP HANA and SAP IQ, 12.1 petabytes in size. And I can get the real-time insights out of that. There are SAP products that are built to help customers act, acquire, analyze. So I can help you acquire the data through streaming analytics, through ELT, through data connections. We have advanced analytic capabilities in HANA and products. We have visualization, and we have BI and reporting tools. We have the big data development tools and line of business applications that help people act on the data that they see. And around that, we have the data science layer. And this is really important. One of the things I talked about earlier in the presentation was how you actually implement this and how you do it. And SAP has a data science team and a services team that is dedicated to helping customers understand what their big data projects can do. We have a bunch of workshops that can help you look and lever how big data works, and can lever what big data can do for you, and can not just help you do that exploration through a workshop and say, what is it that you have in terms of data? What is it you could do in terms of big data projects? But also, at the point of implementation, once you've decided to do it, can actually help you implement that and bring it to life in your company. So we do have a value by marrying SAP and HANA to get that real-time business result that you need. You have unprecedented insights combining unstructured and structured data for insights that you could never get before in the HANA platform. You have advanced analytics, predictive capabilities, text, spatial. We have KXC and SAP Infinite Insights that will help you drive that to get that instant in-memory result. And you have Apache Hadoop, where you can do that data exploration, you can do the pre-processing, you can uncover the nuggets of information from the large volumes of unknown data. Figure out what it is important and determine the value of that and either move it into HANA or set up pre-processing to virtualize a table from that storage. And that gives you the chance to offload or archive data. And, I don't particularly like this slide. It's a slightly older one. It's not just cold data. It's time-sensitive data. So HANA has data that needs immediate response, and less time-critical data is what is stored in Hadoop. But the joy of this is I now have an archive, and this archive can grow to an infinite size, but the archive is still readily accessible, which will change the way we do business. SAP is agnostic. It will work with Cloudera. We are certified. We have a reseller agreement with Hortonworks. We have a reseller agreement with Intel for as long as it continues to sell its product based on its announcement last week. And we have certification with MapR. So we will work agnostic in any of this. And you can learn a great deal about this if you go to the SAP HANA Academy. So if you go to www.saphana.com, go into the community and go into the HANA Academy, there is a great deal that will help you on how to implement this, where to implement this, how to do the R integration, how to access the predictive capabilities, how to hook into Hadoop. One thing I want to highlight really quickly to anybody that is interested in this, we are currently hosting SAP Innovation Award, and there are 3 categories in the big data area. Big data itself is one of 3 categories, and there are 3 subcategories within big data. So if there is a big data project that you are working on and you want to submit it for consideration, there is a chance to actually win tickets to a Decode event and also win $10,000 for a charity of your choice. So with that, and I've timed it down to the 15 minutes that I wanted left for questions. Are there any questions? Thank you.